So welcome everybody. Today I'm going to talk about hybrid search with Apache Solr. So a very short introduction about myself. Born in Tarquinia, an ancient Etruscan city in Italy. I'm an R&D software engineer and director of my company, SIS. I have a master's degree in computer science and I'm program committee member for the European Conference on Information Retrieval, SIG-IR, and the SIAS. I'm a Lucene committer and Solr committer and PMC member. Been working for many years in information retrieval and I'm quite passionate about it. And in my spare time, I play beach volleyball and I snowboard. Quickly about my company, we are headquartered in London. We work with open source. We are search specialists and also active contributors. So we contribute a lot back. We speak at conferences. We contribute back support, code through the mailing list. And the current hot trends for our work are large language model integrations with search, vector-based search, natural language processing, learning to rank. We've been maintaining the learning to rank integration in Apache Solr for a long time, and we are still contributing to it. Document similarity, so the more like this, and search quality evaluation. We contributed an entire framework, rated ranking evaluator, to the community to evaluate Lucene-based search engines. And also relevance tuning, but that's something we've been doing for a long time. So this is the agenda for today. So we're going to start with the limitations of vector-based search and why we may need hybrid search. Then I'm going to talk about the current status of hybrid search in Solr, so what you can do right now. And then talk about both the retrieval phase, so how to retrieve documents from your corpus of information in an hybrid way, and how to rank them, so how to order them. Finally, some future works and some upcoming talk about open pull requests and developments. So you should be all decently familiar with vector-based search, but just to give you like a very quick summary. So how does this happen? You get an embedding model, so a large language model fine-tuned. Can you hear me right? Because I see like sometimes some echo. Okay, it's a small room, so it should be okay. So with vector-based search, you start from an embedding model. So you get a large language model, you fine-tune for sentence similarity to be able to encode text to numerical vectors. So that's the first step. Then you index your vectors in some data structure, for example, a graph, like it happens in Lucene and Solr, and then you query vectors by similarity, by distance, effectively. So this is more or less like the classic vector-based search pipeline. So you get your documents in input, you use a large language model to encode those documents to vectors, you index your vectors, and the same happens at query time, and then you run a k nearest neighbor search to look for the neighbors for the query vector. You can measure the distance between vectors in many ways, and this becomes a similarity in Apache Lucene and consequentially in Solr. So there is the cosine distance, or you can go with like Euclidean, and pretty much. There are many others. You can implement your own if you like. So we are not going to spend much time on vector-based search, but let's talk about the problems with vector-based search. So first of all, low explainability. So if your vector-based search works well, that's great. Yay, everything is working fine, you get great results, but what happens when you're not? It's very difficult to explain because many reasons. So high dimensionality. So you have like numerical vectors that are very long. Even if they are short and they're like 512, they are long from a human perspective. And sometimes they are even bigger, so longer sequences of numerical values. Then the dimensions themselves, so each feature, each element in the vector has no meaning for a human. So there is no semantic. Most of the time, I'm talking about general and generic embeddings. Sometimes you may have like a meaning for the position in the vector, but it's not the generic case. And what about the values as well? So you don't really know how a single value in your numerical vector affects relevance. So you have no idea if you change like a single value to a different, I mean, is it like an increasing of it, improving relevance or not? It's not simple. And so what you can get in terms of explainability effectively right now, more or less is just like it is within top K in terms of approximate distance and similarity or not. There's a lot of research happening. There are like different kind of embedding models and applications of large language models, but still, this is a huge problem. And what about lexical matches? So search users are used to get lexical matches, so keywords matching with your documents. So if you give them a vector-based search engine and they won't find their keywords, it's very likely they will complain, like, oh, why is I don't get the results with my keyword in the title? Or in the body, why is just at the 5th position rather than the first one? So this is a problem because anyway, you can explain, oh, it's because of the semantic. Maybe the vector search didn't perform that badly, but still, if you don't get the keywords, users are going to complain. Low diversity. KNN vector-based search on its own is going to look for neighbors to your vector. So by definition, it's going to go with similar vectors to the input one. And sometimes you want diversity in your results. So you don't want just n clones of your original query vector, let's say. So, you should add more logic on top. But, by definition, you're going to get low diversity. So how can we mitigate these problems with hybrid search? So I said mitigate because, right now I'm not that sure that hybrid search is here to stay. So if in the future we get like better and better embedding models and better large language models, we may not need to mix up different like retrieval approaches or different rankings. I don't know. I mean, right now, in my opinion, it's going to be useful. I don't know for how long. What can you do with hybrid search? You can combine keyword-based search with vector-based search, or in general, any retrieval and ranking model with another. And not necessarily just two of them, potentially more than one. The focus of the talk is going to be anyway what's currently available in Solr, and it's going to be pretty much combining two models. So what you need to do is the retrieval of two sets of candidates, and then you want to combine the set into one set and rank the candidates according to specific rules. So in the case of pure hybrid search, one set of the results is coming from the lexical matches with keyword traditional search, and a set of results is coming from k-nearest neighbor search with the query vector. So you then combine those results and you rank the candidates. So let's see what we have in Apache Solr. So first of all, with Apache Solr 9.0, May 2022, my company introduced and sponsored the support to KNN search in Apache Solr. So I did the main contribution, but also some of my colleagues helped. And of course, we got the review and help from other members of the community. And we got the release with Apache Solr 9.0. So since 9.0, you can do vector-based search in Solr. And we are keep improving it, and more stuff is coming. So let's start from the retrieval stage. So how can we get two sets of candidates and combine them? The first approach is union of your candidates. So we can use the Boolean query parser in Apache Solr, which is a component that takes in input a query and build behind the scenes a Lucene query, which is a Boolean query. And if we want to represent the union of the two candidate sets, we can use the should Boolean operator with a lexical query and one with a vector query. So this is the syntax. You can use like variable resolution to introduce the lexical query. For example, in here we have an edismax query on the text field. It can be a Lucene query parser query, whatever you like. And then you have a vector query, which is a KNN search query. The syntax for the KNN search query is taking in input the field, which is supposed to be a vector field, and the top K you want back, and then you put your vector, your query vector. So what happens is that you retrieve the candidate sets and you combine them in a union. So the cardinality of the combined set is going to be less than equal than K coming from the vector-based search plus the number found of the lexical query. Of course, you may have like the same result within the lexical query and the vector query, so that's the reason you have like less than equal the sum of the results. And we won't have any duplicates in the final result set. So this is managed by Solr. Another option is the intersection. I'm going to show like simple approaches, but they may be useful for your use cases. So intersection, what you do is effectively you use again the Boolean query parser in Solr, and you combine in a different way the candidate sets. This time you intersect them. So you have again the lexical query, whatever it is the query you like, and another vector query. So in this case, what happens is pretty similar to post-filtering. We will see later what post-filtering means, but effectively you take the K documents coming from the vector-based search and you intersect them with the lexical results. So you get only the ones that are in both the candidate sets. So let's talk a little bit about pre-filtering and post-filtering with vector-based search, because I think this is quite an important topic. So before Solr 9.1, all filter queries applied to vector-based search were post filters. So you were retrieving the top K neighbors and then reduce this candidate set. Okay, so post filtering. Potentially you may end up with 0 results. After 9.1, filter queries by default will be pre-filters for vector-based search. So this means that these filters are applied during the construction of the result set of the top K in the graph. So this means that basically you get the top K, of course, if you have enough vectors. You can still do post-filtering, and I leave here in the slides the link to the Apache Solr documentation, because you can specify post-filters in general in Solr in some ways, specifying the cost of a filter, for example. But anyway, it's not important right now, so take a look to the documentation if you need to do that. Starting from 9.6, so effectively the last version of Solr we have right now, there's more flexibility with additional KNN query parameters. It complicates a little bit the situation, but it gives you more capabilities. So we have now an additional parameter in Solr for, this is a local parameter for the KNN query parser, which offer you 3 new local parameters. So we have the pre-filter, and then you have the include tags and exclude tags. they must be used exclusively. So, or you use the pre-filter, or you use a combination of include tags and exclude tags. The pre-filter specify an explicit list of pre-filters to use with your vector-based search. So you can ignore the FQ. Those are going to be used for post-filtering. You specify directly the pre-filters as a local parameter for vector-based search. Or you may include or exclude tags from FQ. So in Solr you can tag, you can give a label to your filters, because potentially you want to use them with faceting, you want to exclude sometimes from facet calculations and stuff. So with include tags and exclude tags, you have the control of specifying which filters among the FQ should be pre-filters and what not. And so the default is that the main query is going to be like, I mean, if you don't do anything, it's just, as says, is in the version greater of 9.1, so everything is a pre-filter, but then you can include or exclude tags. And, you know, this can be like useful specifically if you're using like potentially the vector-based search KNN query parser in FQs, in subqueries, and this sort of more advanced stuff. Some other use cases why you may want to use, for example, include tags or exclude tags, or pre-filter to use lexical filters with your vector-based search. Potentially, you are drilling down on facets. So when you use facets, you're adding filters to effectively navigate a result set and reduce the scope of your result set. So if you were to use just the filters as pre-filters, you may just end up with a completely different result set. Still, the top K will be returned, while you expect your user to see a reduction in your result set. So that's one possibility. You want to effectively like use them as post filters. And also, you may have like filters in Solr, you may have filters saved in your cache. So using like the include, for example, of only some of the tags, you may be able to reuse some of the caches you have, for example, rather than all of them. These are scenarios that could happen. So we decided it was like an interesting contribution. So let's talk now about the ranking. So how should you order the results? So once you have a candidate set that is built both from a lexical traditional search and a vector-based search, how should you rank these results? So first of all, it's an open problem. It's not like that easy, but you want a score that reflects like the best relevance ordering possibly. KNN candidates will have a score from -1 to 1, most likely from 0 to 1, but it depends on the similarity you use. On the other hand, lexical candidates present right now an unbounded score, potentially on a completely different scale. It's not necessarily a probabilistic score, it's not between -1 and 1, so you can't just combine them, like sum them. You won't get like interesting results. So what are the options right now? So as I said, it's not a resolved problem, but let's see what we can do. So this is going to be a little bit more complicated if you're not that fluent in Solr, but let's try to explain what you can do. So one option is if you can sum the scores from your lexical search and your vector-based search, but not like straight away, but normalizing the score of the lexical side of things. So you can see in here, we have a Boolean, again, the Boolean query parser. This time, you have a filter clause. So the filter clause won't affect the scoring. And the filter clause will just do the retrieval of documents, and then the must clause will rank the documents in the results. So the retrieval stage is pretty much the same expression we've seen before. So it is a Boolean query parser, and we are again combining, in this case, is the union of the lexical results with the vector-based results. Then for the ranking stage, this becomes a little bit more complex. So you see in here the func label. It's the func query parser, stand for function. Okay, so you can define a function. In this case, is a sum, because we are talking about sum, the normalized scores between the lexical and the vector-based search, and you are summing the result of the score for the query normalized lexical query and the vector query. So you are defining the sum here. Now let's see how the normalized lexical query looks. Again, it's a function and is a scaling function. So this scale the result, so the original score you get for your lexical query between 0 and 1. Of course, 0 and 1 are parameters, so if for any reason you need something different, you can do it. So this is the one you see like in orange are function queries in Solr, so specific functions you can use. And finally, you have the lexical query, which again is just your lexical query, whatever it is. And the vector query, which is a KNN query. Okay, so you get, in this way, you get a sum of the scores, and it is normalized. You can do pretty much the same, but multiplying. That's another option. Is it better? There's no evidence. I mean, it depends. You should always evaluate your results. So, summing, multiplying them. In some instances can be okay, one, in some instances the other. I won't spend any time on this. It's pretty much the same, just you have product instead of sum. And the, let's say, most complex option is using learning to rank. So multiple factors affect ranking. So as we've seen, there's no simple answer. Like, should we use the sum? Should we use the multiplication? It's not easy to respond to this. You can do manually. You can do manual tries and check this and that, but it's not ideal to do that. So in Solr has been introduced since 6.4, thanks to the original contribution of Bloomberg Learning to Rank support. And from 9.3, my company sees we contributed the first support to have vector similarity as a feature. This was a Lucene contribution and a Solr contribution. Then there's been also like some additional improvements on the Lucene side, and that's great. It was a first step. So, if you want to sponsor us or sponsor the Solr project, my team, to do Solr contribution, feel free to reach out, because we are still working on it. So learning to rank, I don't have time right now to explain you in details, but with learning to rank, what you do, you build a training set where you associate a ranking to a pair of items, query and documents. And then you train a machine learning model to combine this effectively the way you calculate the score out of the feature vector. So what you do is you define the features. So these are elements that affect the ranking. For example, the lexical score, that can be the normalized score we were talking about, and then the vector similarity score, which can be, for example, the dot product using float 32 representation of elements in the vector between the query vector and the content in a vector field for a document. And then how do you combine these two features is the model that decides. So you can have like a linear model maybe that will just sum them and use a multiplication factor like a weight for the lexical score and a weight for the vector similarity score, or maybe, like you could use decision trees, regression trees, neural networks to combine your features. This is just an example of learning to rank query and how you can re-rank your results using effectively like the features I defined before. So feature works. Reciprocal rank fusion is a completely different way of mixing up results from different functions, retrieval functions, and ranking functions. I literally opened the pull request like 3 days ago, and I'm going to talk about this at Berlin Buzzword in literally like 1 week, more or less. And it's a way of combining results and rank them based on their position in the ranking rather than their score. So it's quite a simple algorithm, but putting it into Solr was quite a challenge. So this is something coming. And a quick plug for a training, a workshop that is happening tomorrow here at Community Overcode. The AI side of Apache Lucene and Apache Solr. I'm going to host this training live here. And I'm going to talk about all the most recent development in Apache Lucene and Apache Solr regarding AI. So we are going to start with, for example, learning to rank, vector-based search, all the recent improvements in Lucene from that perspective, and what's coming to Solr as well. So it is an exclusive training for the participants of the conference, but you need to register because it's a paid training. So there is the QR code if you are interested, and you can register. Please remember, if you come tomorrow, it's from 2 p.m. to 6 p.m. Please remember to register. There is a blog post I wrote about hybrid search with Apache Solr, so you will find all the different instructions and REST API calls there, so you can, try them. And thank you for your time.